Hello everyone. Welcome back to our journey into mathematics. Let me ask you a simple question. Have you ever tried building a paper house with matchsticks or watched an architect's blueprint? Every line they draw must meet another line at just the right angle. Without understanding lines and angles, buildings wouldn't stand straight, shadows couldn't be measured, and even light itself would behave like a mystery. So today, let's dive into the introduction of lines and angles. In geometry, we start with something very simple but powerful. Just two distinct points are enough to uniquely determine a straight line. Think about it, connect point A and point B, and you've created a line no one else can change. From such axioms, we deduce powerful theorems about lines and angles. Now, when two lines intersect at a point, or when one line, which we call a transversal, cuts across two or more parallel lines, beautiful angle relations are formed. And through deductive reasoning, we prove statements based on these observations. This is the very foundation of the chapter. Now let's look into our daily lives. Suppose you want to build a model hut for a school exhibition using bamboo sticks. Some sticks must stay parallel, some must meet at neat angles. If you don't measure them properly, the hut might collapse. Similarly, when an architect draws a plan for a multi-storied building, they rely on intersecting and parallel lines to maintain the design. Without mastering these angle properties, no stable structure could be drawn, let alone built. Angles aren't just in buildings, they're in science too. When we study how light bends while passing from one medium to another, we use a property called refraction. Here, intersecting line geometry is crucial to measure the angle of incidence, we say I, and the angle of refraction, we say R. The law governing this is called Snell's law. It is written as n1 into sine I equals n2 into sine R. This single formula explains how lenses, prisms, and even your spectacles work. Let's move into mechanics. Imagine two forces acting on a body, say F1 and F2, making an angle theta between them. To find their combined effect, we use the parallelogram law of forces. The resultant is given by R equals square root of Fn square plus F2 square plus 2 Fn F2 cosine theta. This equation shows us how much the two forces strengthen or weaken each other depending on the angle theta. Think about pushing a box with your friend. If both push in the same direction, the box zooms forward. If one pushes sideways, the effect changes. Angles decide the outcome. Now let's step outdoors. Suppose you're looking up at a tall tower and you measure the angle your line of sight makes with the horizontal ground. That angle is called the angle of elevation. Similarly, if you look down at a ship from a lighthouse, the angle your line of sight makes downward with the horizontal is the angle of depression. Here we use a simple trigonometric relation tan theta equals h over d, or tangent of theta equals height divided by distance. Surveyors, sailors, and even drone operators use this exact relation daily to calculate heights and distances. Let's solve a quick example together. Suppose a tower casts a shadow of 20 meters and the angle of elevation of the sun is 45 degrees. How tall is the tower? We use the formula tan theta equals h over d, substituting values, tangent of 45 degrees equals h over 20. But tangent 45 equals 1. So, 1 equals h over 20, which means h equals 20 meters. The height of the tower is exactly 20 meters. A neat result, and it checks out because whenever the angle is 45 degrees, the height and shadow length are equal. So, to wrap up today's session, 2 points make one line, and these simple foundations lead us into deep angle properties. We saw their importance in construction, in optics through Snell's law, in mechanics through the parallelogram law, and in surveying using tangent ratios. Geometry of lines and angles isn't just abstract, it connects directly to our real world. And that brings us to the end of our introduction to lines and angles. In the next video, we'll explore the detailed angle relationships formed when lines intersect or when a transversal cuts parallel lines. Stay tuned because the real fun with geometry has just begun.